I'm a geomicrobiologist. That is, I look at the microorganisms on the planet that live in rocky habitats, and particularly in caves. And I'm an astrobiologist, so I think about how these kinds of science issues can be applied to the search for life on other planets.
My name's Dr. Larry Crumpler. I'm research curator here at the New Mexico Museum of Natural History, specializing in volcanology and space science. One of the big goals of NASA's exploration of the solar system has been to understand the origin of life in the solar system, and the Extremophiles here in New Mexico are good examples of the types of life forms that we might encounter on other planets if they still exist on places like Mars and even in the other places like Europa or the outer planets. Early Earth was a very dynamic and changeable place, extreme environments taking place. The atmosphere itself was a totally different composition than what we see today. More poisonous, essentially, to life as we currently know.
So it was a very different planet in those days, and by looking at the metabolism of organisms that are living in habitats that are similar in some ways to early Earth, we hope to get clues about what those very earliest organisms may have been like. In the case of Carlsbad, we also think that sulfur had a role to play by way of sulfuric acid. The pool fingers in the Paleo Pool were some of the first types of these structures that caught our attention. They had sort of drapey, webby connections between them. And that was very reminiscent of some of the live microbial growths that we had seen in other environments. We took a very small broken piece of that and started to do cross-section cuts through it. We saw that there were fossils of microorganisms embedded in that material. When you have microbes living in a cave pool, one cave pool should be very much like another cave pool, and yet we were seeing a lot of different diversity. We think that the rate at which water is slowly dripping into a cave pool is probably important. That kind of water may be delivering nutrients from the surface slowly over really long periods of time. We also think that the depth of the pool probably controls which microorganisms are happiest in any given cave pool environment. The beautiful little nests in which these little spherical structures that we call cave pearls, microbial biofilm is involved in this process. And the biofilm, of course, is organic material, so it's pretty different from the calcite mineral that the formations are made out of. And so we think that the microbial presence itself is actually responsible for creating these unusual geometries and producing the cave pearls. This kind of microbial activity in environments with very low organic nutrient contents are interesting to us because we infer that the earliest organisms on the planet were getting by in a biosphere that was greatly reduced in terms of its total production of biomass and hence microbial food than we see today. Chosa Draw and Parks Ranch Formation caves, where the caves are made entirely in gypsum material, it's a very different process. So there, sulfuric acid didn't play a role, but the gypsum mineral plays the primary role of being the bedrock. Within the surface exposed gypsum, a lot of weathering goes on because it is so soluble. So fractures get made where the rock is being exposed to the atmosphere. Within those little fractures, organisms rafting on tiny particles are deposited within those fractures. And the fractures act like a refuge for these organisms. These then develop over time into complex microbial communities. Now, the presence of these organisms actually contributes to the further widening of these fractures. We see that even though these are somewhat related types of caves in terms of some of their chemistry, the resulting cave is wildly different between these two different settings, and in fact the microbial inhabitants of these two different types of caves are really very different. So the organisms that live in Carlsbad are used to a carbonate-dominated, very low nutrient environment, whereas the organisms that live in the gypsum caves have to be able to tolerate very saturated solutions of gypsum.
Currently, our sort of very scientific view of the world says that life is simply a self-replicating molecule. So it's really simply a result of the complexity, chaos of the universe. And as to whether life develops into intelligent life, or as we define it, that's another question altogether.